Let's talk about exponential functions. So linear functions have a line. That line can be increasing or it can be decreasing based off of our slope. Our slope is our steady rate at which that function is increasing or decreasing. So maybe my hourly wage that I get paid per hour. Or if I'm taking a taxi ride, how much I'm paying per mile. It's a steady rate, it's not changing. When we think about an exponential function, it can also be increasing or decreasing. But your rate is not always going to be the same. Exponential functions, often when they grow, they start out growing very slowly and then kind of get out of control. So if we are looking at maybe a sickness or a virus, often I think about the show The Walking Dead. There's hardly any zombies, and then before you know it, the whole world is covered in zombies. So things that grow quickly or decay quickly are going to be exponential. Let's talk about that a little bit more. So with exponential functions, you have exponential growth and you have exponential decay. This is the form of our exponential function. There's an a value, and it's being multiplied by a b to the x. That a value on the outside is your initial amount. Now the initial amount can be 1, so you might not always see an a, so that's okay. Your a cannot be 0, because if you multiply anything by 0, it's not going to be there anymore. So if I'm talking about investing money, and I have an initial amount in my bank account of $500, then that a will be 500. The b will be the rate at which my money is going to grow. If a problem mentions that you're doubling or tripling, then your rate could be 2 or 3. So if you see the word double, 2, triple, you get the idea. If it's a quadruple, 4, that could be your rate. Something doesn't have to grow, though, at a whole number rate. It can be a percentage. And so if you have a percentage, like 50%, it'll be written as a decimal, 0.50. So this is my initial amount. It's also going to affect my vertical stretch or shrink. So how close to the y-axis that function appears. Whether it's growth or decay depends on that b value, your rate. If I'm growing at a rate that's bigger than 1, so if I have the zombie situation and I have 5 zombies to start with, and every time a zombie bites a person, then 2 more zombies are growing from that, then that's going to be the doubling part there. So every time a person gets bit, they're going out and biting 2 more people. That's going to be growth. Okay, if I'm looking at probably a more real life situation, because we don't have zombies everywhere, you could talk about an illness or another virus spreading when it's cold and flu season. 5 people have some sort of a cold, and each of those 5 people interact with someone, and that gets 2 more people sick. If this rate is not bigger than 1, if it's in between 0 and 1, so a fraction or a decimal, like the 0.50, then that's decay. So if you've ever taken a chemistry class, or maybe you've heard of radioactive decay, the initial element there's so much of that element, over time, the element breaks down. You'll notice that neither one of these functions touch 0. I have a dotted line here on the x-axis. That is what's called a horizontal asymptote, and that's at y equals 0. Exponential functions cannot touch the x-axis unless it has been shifted up or down. The parent function will not touch it. There is nothing that you can plug into this x value and get out a 0. Even if I put a negative in for x, or I put a fraction in for x, I will not get 0. It's not possible. My domain will always be negative infinity to positive infinity. I have arrows on both ends, whether it's growth or decay. I can plug anything I want into an exponential function. Now, if we're thinking about a real life scenario that involves time or people, yes, we might change that domain based off of that situation. But if you're just looking at a function, you're looking at the picture of a graph, its domain is all real numbers, and nothing will change that. However, the range is going to be affected by that function moving up or down. If I shift the function up, that's going to shift my asymptote, which will shift my range. This number, your range, what it's greater than or what it's less than, will always be equal to the horizontal asymptote. If I reflect my function and it's upside down, then my range is going to become less than 0. So for example, if I have y equals 3 to the x plus 1. Now, you could go to Desmos if you don't know what this looks like. I'm going to sketch it, and I will talk about Desmos here in just a moment. Anytime you add on the outside of the function, that is going to shift it up that many units. So where my horizontal asymptote is normally at 0, it's now going to be at 1. I'm basically shifting up from 0 to 1. So instead of my function riding along the 0, I'm now going to ride along the 1. The 3 is just my rate. The bigger that 3 is, the more steep my function will be. So if this 3 was a 4 or a 5, you might see this function get closer to the y-axis. Regardless, my domain is always going to be negative infinity to infinity. Or you can also say all real numbers, and this is the symbol for that. My range is going to start right after this 1. We don't want to start at 2 because we're going to miss out on decimals. So I'm going to start from y is greater than 1, or I can write it like this, 1 to infinity with parentheses. This allows me to get those values that are decimals, so starting at 1.0001. We do not include 1 because we cannot touch 1. My horizontal asymptote is always going to match that vertical shift. It's always going to match that range. These numbers should be the same. If I don't have a vertical shift, then it's going to stay at 0. My end behavior. When I'm talking about my end behavior, I'm talking about my left end and my right end. My left end is going to the left, which is negative infinity. So when I'm talking about the left end, I'm going to the left, which is to negative infinity. when I'm talking about the right end, I'm talking about the right, which is as x goes to positive infinity. What we want to do is we want to look at where the y values are going. My left end is leveling out. It's riding right along the asymptote. So my left end is approaching 1 because that's my horizontal asymptote. My right end is going up in the air and it's not stopping, so it's going to infinity. So we are just looking at what the left end is doing. As we go to the left, my y value is approaching 1. As we go to the right, my y value is going up. It's approaching infinity. Let's look at another one. With this problem, I have 3 to the x plus 1. Notice that the plus 1 is up in the exponent. This will shift our function to the left. If you don't know that, it's okay. You could always graph this in Desmos and look at the graph in Desmos. When you shift an exponential function to the left or to the right, it's not going to affect the range. It's not moving up or down. So a lot of my information for this is really going to be the same as the parent function. My domain for any exponential function is always all real numbers. My range is going to have to do with that value that's being added on the outside of the function. There's nothing there. You can think of it as a plus 0. So I'll say y is greater than 0, or 0 to infinity. My horizontal asymptote should match that number. If my function were flipped upside down, then I would just flip the direction of my inequality sign. My end behavior, I'm going to look at my left end and my right end. So as x goes to the right, or to the left, let's look at left first, negative infinity, my left end is approaching that horizontal asymptote of 0. These numbers shouldn't be different. You shouldn't have a 1 here, a 0 here, and something else here. These should all match. When I go to the right, y is going up in the air to infinity.